Oh, that grass is so good. I wonder what flavored grass we're going to get tomorrow. I bet you it's grass flavored. Mm. Hi, folks. Today we're going to be going over bowl sheet. And yesterday we did bird sheet. And in the future, we'll do lots of other kinds of sheets as we are going along. You will need your periodic table out for today. The goal of today's 20s worksheet is for you to do the problem and then to watch the video part and then do the next problem and then watch the video part. You will learn absolutely nothing if all you're doing is copying everything down. And you do, in fact, need to know this skill. So on this first part, it's asking you some questions about what do the parts of a chemical reaction, what are they? The stuff on the left-hand side, are called reactants. And they react together to produce or yield products. And in a balanced chemical reaction, the big numbers like the 3 in front of 3H2O, those are called coefficients. And those small numbers that are below the letters, those are called subscripts. Like a submarine is below the water, those little numbers are below everything else. Now let's go over the diatomic elements. So the diatomic elements are found right on your periodic table. They're darkened in right here. They make a little 7. So we got H2, O2, N2, F2I, 2Cl2. We got 6 of them there. What am I missing? Br2. All right. So those are the diatomic elements. The reason we point those out because those should be the last things that you solve in balanced equations. They're all by themselves. If you change their number, you only change it for that element. So these are the ones you should be attacking lastly in all balanced equations. And you can use these numbers in the coefficient blank to balance these elements, and these are for diatomic elements. This is the only time that you should be using the 0.5 method is on these diatomic elements as we're going along. These are the different types of reactions that we have on your sheet. We will use them. We'll make you aware of them. They will never, ever show up on any kind of test for us. So we're just making you aware of them. So here's our first one. We look at it. We write down the elements in the middle. It's up to you if you want to put ones in these blanks right away. Mr. Brosnan and I usually do not do that, but if that is something you wish to do right away, nothing in the blank means that there is a 1. So now we've got to count up the number of each element. So we have 1 sodium on this side, and we have 1 sodium on this side. This subscript right here says we have 2 H's on that side. And if we go over here, this means H, H2, that's what that means. So on this side, we have 2 H's right there and another one right there. So we have 3 H's on that side. We have 1 oxygen on the left side, and we have 1 oxygen on the right-hand side. All right, so now we need to balance that out. So the sodiums are good. The hydrogens are not good. The oxygens are good. Hydrogen is a diatomic element. We want to save that for the very last thing as we're doing it. Actually, we want to save oxygen and hydrogen for the last things, and diatomics, anything with that, let's go like with a 2 like that. We want to save those for the absolute last. So I have to balance out my hydrogens here. So I got 2 hydrogens on this side. I have 3 hydrogens on this side. How do I balance that out? Pause the video. Take a good minute or 2 and see if you could figure that out. A lot of learning will occur if you can figure that out on your own. If you're just watching as you're going along, you're not going to learn much. So I need to get 3 hydrogens onto, or 2 hydrogens onto this side. And one of them is right here. So how do I make this just 1H? And I do that by putting a 0.5 in that box or on that line. That 0.5 is saying I have half of an H2, which is an H. And now everything balances out. I now have to multiply a 2 through this whole thing to make it work out, because I really can't have half of an H2. So 2 times 1 is a 2. I cross it out, I put the number up there. Cross the number, I put it out there. Cross out the number, I put the number up there. And 0.5 times 2 is 1, and everything is balanced. You should absolutely be trying to do this problem as we're going along. One little thing on the previous problem, we are not going to go about, or not going to state what happened in each of these problems for the people that are at home. If you were in class, we would be doing some demonstrations, but to conserve some time, you do not have to worry about that far left-hand question of what happened. So again, the video should be paused. You should be working through this problem and then checking out to see if you actually can do it on your own. So what I'm going to do is I'm going to write down all the elements. And then I'm going to go ahead and I'm going to figure out the number on each side. This whole part below this reaction right here, that's just math. We're never going to correct it. We're never going to look at it. It's just a place to collect some numbers and keep track of things on each side. So if I look on the left-hand side, I have 1 carbon, and I look on the right-hand side, and I have 1 carbon. I have, right over here, I have 4 H's. 3 of them are right here, and 1 of them is right there. And on the right-hand side, I have 2 H's. And on the left-hand side, I have 2 O's there and a 3rd O right there. So I got 3 O's on the left-hand side. And on the right-hand side, I have 2 O's there and 1 O there. So I have 3 on that side. Now I'm going to do a little erasing just to clean things up. As we're going through this one, I'm not going to put the ones in the blanks right away. You can make that decision if that's what you wish to do. All right, so it looks like everything's balanced but the hydrogens. All right, so it should be pretty simple. So if I have 4 hydrogens on the left-hand side, if I put a 2 right here, that's like going H2O, H2O. That gives me 4 hydrogens. Oh, but crapola, that screwed up my oxygen count. So now I have 1 O, 2 O's, and another 2 O's. So now I have 4. All right, so now how do I get 4 oxygens onto the other side? Well, remember there's 1 right here, and this O2 is 2 of them. So that's 3. If I put a number in here, I change the carbon count, the hydrogen count, and the oxygen count. So that's not the route that I want to take. So what can I do here? Well, again, I'm trying to get to 4. So if I put a 1 in this blank, that's O and O, that's O2, and I have an O there, that's 3. And that doesn't work. If I put a 2 here, that's 2 oxygens, so that's O, 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 that's 4, that's 5. That's too many. Do we have a number that's between 1 and 2? We do. It's 1.5. We put that 1.5 in there. We really can't have 1.5 molecules. So we multiply the whole thing by 2. And 2 times 1 is a 2. And 2 times 1.5 is a 3. And 2 times a 1 is a 2. And 2 times a 2 is a 4. You can see how I cross them out and I put the other numbers on top. It's easy to understand what's going on. Again, we're not going to worry about what happened with this reaction. This is a combustion reaction, though. All right, we're going to go over this problem right here. Again, the video should be paused. You should be trying to do this all on your own. And when you're done, or if you get stuck, then you should watch. So I go CA, I go C, I go H, I go O. It doesn't matter what order you put them in. It really does not matter whatsoever. I have 1 calcium on the left-hand side, and I have 1 calcium on the right-hand side. And I have 2 carbons on the left-hand side, and I got 2 carbons on the right-hand side. I have 2 H's on the left-hand side. I have 2 H's on the right-hand side. I have 1 oxygen on the left-hand side. I have 1 oxygen on the right-hand side. Oh, it's balanced. Done. Some of them go that quick. Again, don't need to worry about the kind of reaction or to state what happens. All right, so we have this one. So again, you should be pausing the video, trying this problem on your own. Otherwise, you're not going to learn anything. Play the video when you're done or when you get stuck. Carbon, hydrogen, oxygen. 2 carbons on that side, 1 carbon on that side. 2 hydrogens on that side, 2 hydrogens on that side. 2 oxygens on that side, and 3 oxygens on that side. So remember, we're going to save H and O for the last, towards the end, and diatomics are going to be the very last thing that we do. So second to last, absolute last steps. So I look at this, I need to balance out the carbons. I can do that really quick. I put a 2 right there. That changes my carbon count right there to 2. But it also changes my oxygen count. So 2 CO2s, that's like CO2, CO2. So that's 4 O's now, and there's my 5th O. So I can now have 5 oxygens. I'm going to erase a couple things just to clean it up a little bit. So now I need to get 5 oxygens over on that left-hand side. So if I put a 2 here, that's going O, that's 1 O2. Here's another O2. That gets me 4 O2s. If I put a 3 here, that's 6 O2s. So I get 4 or I get 6, but I need 5. So what do? I go in between these numbers and I go with a 2.5. That gets me 1 of those oxygens gone and brings me exactly to 5 O's. I then go through and multiply the whole thing by 2. So 2 times 1 is a 2, 2 times 2 is a 4, 2 times 2.5 is a 5, and 2 times 1 is a 2, and I am balanced. Do not need to state what happened, nor what type of reaction this is. This is a combustion reaction, though. All right, here we go. Again, the video should be paused. You should be trying to do this problem on your own, and then you play the video when you're done or if you get confused. N and I, and 1 N over there, and 2 N's over there, and 3 I's over here, and 2 I's over here. Both of these are diatomics, so we don't know which one to wait on. So let's just start with the one that we have on top, the N. I need 2 N's on this side, so I put a 2 there. Again, this whole thing right down here, this is all just a mathematics thing. It's a way of keeping track of as we're going along. So now we have 2 N's there, and that would give us 6 I's. So over on the right-hand side, I have my N's balanced, but I need my I's to be balanced. So I need to bring this up to 6. So I put a 3 there. And now I'm balanced. 2, 1, 3. Do not need to state what happened here in this problem. This would be a decomposition reaction. All right. Ooh, a lot going on here. So again, you should be pausing the video, see if you can do it on your own. Got lots of things in this problem. Lots of elements in this problem. So I got 2 NAs over there. I got 1 NA over there. I have 1 carbon. Now don't think this is carbon because it's not. And I have 1 carbon over there. I have 3 O's on that side. I have 3 O's on that side. I have 1 H on that side. I have 2 H's on that side. I have 1 Cl on that side, and I have 1 Cl on that side. No diatomics, kind of want to save oxygen and hydrogen for last. So the first thing that I would do is I'm going to balance out these NAs. It's not hydrogen or oxygen. So I'm going to go ahead and put a 2 there. Now I have 2 NAs on each side, but now I have another Cl as well. So now I have 2 Cls. All right, so again, leaving hydrogen and oxygen for last. I'm going to balance out the Cl. So I'm going to go over to this side and put a 2. That's going to bring me to 2 Cls, but it's also changing my hydrogen count to 2. And holy crap, folks, we're done. It's all balanced. And we are done. All right. Again, do not need to state what happened nor what type of reaction this is. All right, here's one more. Again, pause the video, see if you can do it on your own. Play the video, see if you got it correct or if you get stuck. So we got BA, we got N, we got O, we got K, we got CR. Bunch of different ones in this problem. So how many BAs do we have? We have one of those and one of those. And how many nitrogens? So this 2 right here is saying NO3, NO3. So how many N's do we have? We have 2 N's on that side, and we have 1 N on this side. This 3 goes with the O. It does not go with the N. How many O's do we have on the left-hand side? Well, here we have 6, and here we have another 4, so that's 10 O's. And on the right-hand side, we have 4 and 3, so that's 7. We got 2 Ks on the left-hand side. We have 1 K on the right-hand side. We have 1 chromium on the left-hand side. We have 1 chromium on the right-hand side. If you don't get the initial count correct, you'll never balance these. So it's pretty important that you're counting correctly, taking the time to do that well. You might even want to check with somebody else before you go any further just to see if you have the initial counts correct. Hydrogen and oxygen we want to save for last. Diatomics, the very last thing. So in this one, our bariums are balanced. My nitrogens are not. So I put a 2 there, and now I have 2 nitrogens. But that's KNO3. That's KNO3. So I have 2 nitrogens now. That's good. I also have 2 potassiums now. I have 6 oxygens there and another 4 there, so that's 10 oxygens. And wow, what looked like a very complicated problem only took me 1 step to really just balance that out, and we are done. So that's what we have, folks. At the very bottom, it's asking you for what are some different things that can happen to show that a chemical reaction occurred? And this will come on a little bit later. But a gas can form, a precipitate forms. That's where 2 liquids form a solid. You could have a color change, an energy change, so it could get hotter, it could get colder. Light could be given off. So that is it, folks. And hopefully you did those problems on your own and you know how to balance equations now. Have a good day.